All right, so I have a question here given to me. It says the graph of f of x equals to negative 2 sine of x is drawn below. So we can trace the graph is the solid black one, that one there. All right, we're good. Now, the first thing they say write down the period of f. So remember to write down the period of f. There's two ways because I want you to understand what they said here. I want you to underscore what they said here. They said write. They didn't say calculate. They say write it down. I'm going to do both calculation and writing it down. Well, to write it down, sign must complete the letter S. Look, starting from here. It goes all the way to here. Can you see? So this is 180. This is minus 180. So starting from here, from the beginning, negative 80 to here, it's actually 360. So if we were to render them or give them an answer, I will simply tell them the period equals to 360 degrees. Then I'm done. But if I wanted to calculate it, I would give them period equals to 360 degrees. You could have calculated it. And then I must divide that by the coefficient of x. Let's go back. Remember here, the coefficient of x there is 1. So I'll divide that by 1. So when I work it out, I still end up with 360 degrees. So that would be the solution. Okay, 12.2 says write down the amplitude of h. If h is given by f of x divided by 4. Let's rewrite that as, it's the same thing saying we have a quarter or 1/4 times f of x, all right? So now we are going to give them the amplitude. Let's go back. Remember the amplitude of this one, because you got -2. It will be here, it's 2. It's 2 for that one, f. Is it? It's 2. I can show you the calculations. Now, so which means I'm going to write amp. So the amplitude, it's always positive. So it's going to be a quarter and then times the 2. That will give me, remember, it's 2 over the 4. So that's 1 over the 2. So the amplitude is actually half. All right, we're good. Now, the next thing, which is 12.3, it says draw the graph of that, of cos, open the parenthesis, x minus 30 degrees, close, for the same interval from negative 180 to 180 on the grid provided on the diagram sheet. Well, I can show you a process to sketch this. Let me tell you exactly the process of doing that. Let me see the calibration. The scale is in 30s here. It's already fine. So here's how we're going to do that, which is g of x. You need a pin. That's all you need to do. So you write g of x equals to, it's going to be cos, open the parenthesis. You've got x minus the 30 degrees, close. So I said you need a pin. First is the P for the period, which is 360 degrees for cos and sine, but you divide it by the coefficient of x, which is 1. So I know the period, it's going to be 360. That is from the calculation. Remember, we're currently working with that. Then I said it's a pin, that's P. Now we need I. I stands for the interval. So interval, we are going to deal with 90. All right, 90 divided by the B. Okay, 90 divided by the B. So which means I'm going to divide by 1. So the interval is actually 90. The interval is what the calculator calls steps. Then we need n. N stands for nice numbers. How do you get nice numbers? You take x minus. Okay, let's just put the semicolon. You take x minus 30. I take x minus 30 degrees, equate that to 0. When I solve for x, I end up with x equals to 30 degrees. Good. This tells me my first number will be 30 degrees. On the 30 degrees, I'll keep on adding the 90s. All right. So watch what's going to happen. Because they told us I must sketch this for x is an element of a closed interval, negative 180 degrees, semicolon, to positive 180 degrees. So first, if I want to see where I should start here, by what negative, I take that yellow minus the steps until I get to 180 or just after that. So I've got 30, I subtract the 90, I get negative 60, I subtract the 90, again, minus 150. If I press equals to, the calculator will subtract the 90 automatically. Then it's minus 240. Can you see that? Remember the last part, it was 150. We haven't reached that one. So that means I'm going to have to do my start. My start for me, I'm using a sharp calculator. I only need start. Start is going to be negative 240. If you're dealing with a Kesho, you'll come back and say, okay, I'm going to take 30, but this time I'm adding lots of 90 degrees. You say 90, it's 120, plus another 90, what you get? 210. Then your end will actually be at 210 degrees. That's what you're putting in a calculator. So we go mode, table, we put that equation, which is cos, open the parentheses, it's gonna be alphabet x minus the 30 close equals to g of x, we make it equals to 0 because we are basically looking for the x-intercept. There we go. And then equals to my start is gonna be negative 240, and then equals to steps is my interval. It's gonna be 90. Bingo, there we go. At minus 240, I must put a 0. That is x and y, x and y. At minus 150, I'm gonna put negative 1. So let's start at minus 150 first because it is visible here. So there is minus 150. It corresponds with a negative 1. So there is a negative 1 there. All right, let's see. I know this sketch is not perfect, but I'm gonna draw the line that will kind of guide us, even though it doesn't come accurate, but because the paper it's actually curved, it's bent. All right. So okay, let me not even do that. So let's just say I need minus 150. It must correspond with 1. So my dot should be, let's say, somewhere there. But it's fine. Somebody put it over there. So I'm going to put it there. All right. Well, I changed my mind. I'm going to put those lines to guide me. All right. Let's do that. All right. I put this line, I bend them in a bit so that they follow almost straight. So now let's go put what we've been doing. Let's just do it. Okay. So at here, at negative 150, I need to come down here. So I'm going to use one line that will pretend to be a ruler for me. There, I'm going to put that's a line that is, I'm going to make it a little bit perpendicular to the thing. Yeah, it's more like that. All right. So now there, I'm going to put it there. So that means my point will be here. All right. Then the next one at negative 60, we go for, you see, negative 50, we go to negative 60 now, it's 0. So negative 60, 0 will be right there. That's good. And then the next one, let's scroll down. At 30, we need a 1. All right, so let's go put a 1 by 30 there. So I'm going to put it there. And I'll say, okay, the 1 will be somewhat over there. The next one will be at 120, you get a 0. So 120, there it is over there, it's 0. Now when you go next, it's 210, which is beyond. All right. So now you clear the whole thing. You go just to and let it become normal again, the culprit, normal. Remember, you needed to work with minus 180. So you had cos, open bracket, negative 180. Remember the formula says, the formula that was given, it's minus 30. So you're gonna have to minus the 30 there. All right. And then when you do that, there, what you got is negative 0.8. So let's go there. All right, so negative, come on, 0.8. Remember here it's 1. So it can be straight here. It's just slightly above. Let's say somewhere there, okay? Let's say somewhere there. So if I were to take that line to help me locate it. So there, instead of putting the dot here, put it a little bit above because it's more than half. So it's somewhere, let's use greenish light. I'm gonna put it there. I'm just gonna put it over there. So you can see that greenish part there. All right, and then you have to do the same thing for 180. So it's gonna be cos, open the parentheses. It's gonna be 180 minus the 30, close parentheses. You see, it's the same value, but on the other side. So which means they're basically on the same height when you go the other side. So let's come here. Let's put it there by 180 there. So we kind of like saying, okay, if it was straight, it would come here. So we're not saying there, just above it, just a little bit there. All right, so there it is there. So now your graph, we're gonna need to draw it now. All right, so it's gonna be a sad face for the first part. Let's make that one green. No, I already have green. Let's go purple. So it's gonna be like a sad face because it must curve here. It's a sad face up to here. By the time it stops there, then it wanna try to smile now. It's gonna go there. It will stop right there. All right, so is the other side. It's about to smile. It's curving there, going up. And then there it is there. So then I tell them this coordinates the last one. It's actually negative 180 semicolon, negative root of 3 all over the 2. That's what it is. The last point. Even here, it's the same thing. It's gonna be 180 semicolon root of 3 divided by, negative, I'm sorry. It's negative root of 3 over there. The other points, you can actually see them. All right, so that becomes our G of X graph. All right, let's go on and look at the other thing. Now they say use the graph to determine the number of solutions for where this graph and where that's a point of intersection. We're equating the two graphs. Where do they actually meet this graph? How many times do they coincide? Do they intersect? One of the intersection is there where I'm calling it A over there. and then another intersection is down there, which I'm calling B. So they were asking you where the two graphs intersect each other. So it's only at one point. So in other words, what they say, use the graph to determine the number of solutions. So there are two solutions. There's basically two places where the graph touches each other or cuts each other, two solutions. All right, the next one says, for which values of x is the graph of g greater than or equals to 0? Now, I want you to understand here. That 0 there, it simply means y equals to 0. That is your x-axis. So we want where this graph of g touches the x-axis and then it must be above also. So let's go check where the graph of g, this one touches the x-axis above. It's from here, minus 60 all the way to 120. So if we're to color code it, I will make it red. So that means the red part is the one. So it's starting from negative 60 to 120. All right, so to write that as a solution, you can write it as x is an element of, you use square brackets, y, because there was an equal sign. Then you write negative 60, semicolon, 120, remember degrees, close the square bracket. Another way to write the same solution, you could have written it as negative 60 less than or equals to x less than or equals to 120 degrees. You could have written it there. That's another way to do the same thing. All right, so let's look at 12.6. 12.6 says, for which value of values of x is f of x? Remember, you want the graph of f of x. I think there's an equal sign there. I'm not too sure. Looks like it. Let's just say it's equal sign. F of x is less than g, and the graph of g, it's less than 0. The graph of g is greater than 0. Okay, let's check where g is greater than 0. Where g is above 0, it's actually the one we did before. So I'm going to make it, let's make it red again. But remember, this time there was no equal sign for that. So that means we have an open circle. So here it should be an open circle there. I'm writing it in white to tell you it's actually open there. So if you really want to open it, we can really open it and do that and show you it doesn't touch there. We cannot do that. Then we can really draw open circle. So it's open, it's excluding that. So we want where this graph is greater, the red, while at the same time, the f of x is under. So between minus 60 to 120, where is the other graph under? It's from here. The other graph, talk about the other graph. It's under starting from here. And you see that turquoise color, the one that looks like bluish. It's gonna go like that. No, I shouldn't go beyond. I'm going beyond that. Let me draw a line to help me cut off, to see where I'm gonna cut off. I can't go beyond the 120, so it's there. Yeah, I'm using this as my guideline. So that means I need to come all the way here. All right, so it will depend. Now listen, if that is equal sign, that would mean for the blue graph here, you can have equal sign, shaded dot. But here, remember here, you are supposed to have equal sign only for the blue. But we said we want the blue to have equal sign, the other one not to have. So what's going to win for both to be satisfied? You're going to have to use, and it will be an open circle there. All right? So meaning your solution is It starts from 0. We take 0 and just before 120. So we will write it as x is an element of, we're using square bracket for the 0 degrees, semicolon, 120, we go round bracket. Or you could write it as 0 less than or equals to x less than 120 degrees, okay, without the equals sign. But what if that one, it had no equal sign? What if there was no equal sign? Well, if there was no equal sign, the only thing you need to do is to change the equal sign there. You just put round bracket there. Here you just put that less than without equals to that. So that solves everything, yeah? All of that graph is now done. Thank you very much.